We're solving problem 20 from the 2021 AMC 12A. Suppose that on a parabola with vertex V and focus F, there exists a point A such that AF is 20 and AV is 21. What is the sum of all possible values on length FV? This parabola can be drawn two ways, one like this and one like this. It is important to note that we can draw up some equations that we want to use in this problem because they will be vital to solving this problem. First thing we can say is that D is equal to FV, and we also know that the equation for this parabola, well, if AF is 20 and AV is 21, we can solve, or we solve that the equation for this parabola is x squared is 4dy. Now, we have this, right? Now, since we're talking about point A, we want to find it, or we can express point A's coordinates as P, Q, where these variables can also be expressed as P squared plus Q squared is 441 by square, since you square 441, because that's the square of 21. So now that you have this, you use this by Pythagoras theorem, by the way, and also for this problem, well, we realize that A is 20 units away from the origin because it states that, well, we know that there are points AF is 20 and AV is 21. So, with that information, we get that we can express D, or not, we can express equation for D in the form of Q is 20 minus D. We can then plug this value of Q into this equation. This P squared becoming 4D times 20 minus D, and then plus 20 minus D squared is 441. We can then factor out the 20 minus D in both sides. So this becomes 20 minus D times 20. Well, you're adding this 4D to this other 20 minus D and this 20 minus D squared. So this is plus 3D. This is 441. Once you multiply this out, well, you get that this is 3D squared minus 40D plus 41 is equal to 0. And since we, for this problem, it asks for all the possible values of the length, and we expressed it in this form, we can now utilize Vieta's formulas to get all the values. That's basically negative b over a, which is one of Vieta's formulas, the one we want to use for getting all the values, which is, in this case, 40 over 3. So that's our answer for this problem.